Technology has a fundamental role in all our lives. It is vital for producing food for a growing population, manufacturing new products that fuel economic growth, and supporting the infrastructure that underpins modern life.
Our global population stands to grow to nearly 10 billion people by 2050. With that growth comes an ever-increasing demand for products, infrastructure and services, and a growing burden on our planet's resources and geopolitical relations.
We have a key role to play in delivering the technologies that will enable us to decarbonise and meet global goals for net zero.
We are collaborating with industry to help manufacturing sectors achieve their decarbonisation goals. We have a long-standing collaboration, for example, with Rolls-Royce, which has led to a host of new approaches in casting, in materials development, and in materials manufacturing.
Innovation at our high-temperature research centre is already yielding new capabilities, providing significant time savings in the design and manufacturing of components.
We are leaders in green chemical technologies. Here at Birmingham, we have created a research hub that is engaging with a wide range of industries to advance sustainable chemical manufacturing. This is based on mechanochemistry, a new groundbreaking approach to chemistry that eliminates the need to use or waste toxic solvents.
Our expertise in science, economics and law are addressing the global pressures on strategic elements and the supply of critical materials.
We're developing recycling processes, reducing waste and reusing existing lithium-ion batteries. We have built a UK-first, full-scale remanufacturing facility in Birmingham for rare earth magnets, one of the building block materials for clean growth.
Our interdisciplinary researchers are advancing medical technologies to match longer lifespans. By developing innovative solutions from tissue regeneration to early detection of brain injuries and cancers, we are enhancing the quality of life for patients with debilitating conditions.
By harnessing quantum technologies, we can reveal the invisible, allowing us to look underground, into the sky and inside the human body. Our work with quantum sensors for gravity gradiometer is locating unseen objects buried beneath our feet, a world first, and providing new tools for navigation at sea. Quantum sensing has a huge potential across areas such as civil engineering, infrastructure, navigation, healthcare, timing and radar.
As the world continues to innovate and develop, so must our approach to manufacturing, engineering and healthcare.
Technologies we develop will unlock the potential in our economies, our society, and in the environment.
With our unbound approach to research,
we're changing how the world works.
We research,
we activate.